Okay, so this chapter is talking about the rate of reaction. Rate of reaction. Get ready? Okay, so in the rate of reaction, actually the reaction we use, mostly we have discussed it in the chapters already in Form 4. Okay, but now we want to focus to the rate. Okay, Kada rate. So first, if we want to determine the rate of reaction. Okay, so first we must know it has two types of reaction. One is a fast reaction, another one is a slow reaction. Okay. So be careful on this. When we talk about the reaction, we say it is a faster reaction or slower reaction. Okay. If fast reaction, it takes the short time. Okay, shorter time. Okay. Then shorter time, fast reaction. In other words, it has a higher rate of reaction. Okay. So for slow reaction, take longer time and low rate of reaction. Okay. Now here, be careful. When we talk about the rate here, you cannot use the fast, wrong, or slow, wrong. Okay. You cannot say fast rate of reaction. Is that okay? Or slow rate of reaction, cannot. Okay. So when you can use a fast and slow under reaction, no rate. Okay, no rate. Once you use the rate, you must use the higher or lower. Is that okay? So rate of reaction is a change in the quantity of the reactants or products over the time, divided by the time. Okay. So first, okay, classification of the reaction. So based on what we discussed here, so quickly you fill in the blanks here. Okay, fill in the blanks, and then you try to classify the reaction into fast and slow reaction. Okay, for this. Okay, give you a few minutes. Fill in the blanks on here. Okay, and then try to predict for this one. So whether it's a fast reaction or slow reaction. Okay, already, Now we check. Okay, so we look into this one. Fast reaction, the time taken for the reaction is what? For the fast reaction. So time taken is short, right? Okay. And we call it is a higher rate of reaction. Okay. So this one for slow reaction is longer, longer. So this one is low rate of reaction. Okay. So here, just want you to remember, okay, when you need to use the word high, low, fast, or slow. Is that okay? Now here, okay, fast reaction. Which one is the fast reaction? Which one is slow reaction? Okay, so we check one by one. Sodium and water, this one fast or slow, class? First one, fast. Okay, so fast, you put into here. Fermentation, fast or slow? Fermentation. Fermentation is used to produce the alcohol, right? Slow, huh? Slow reaction. Precipitation, this one fast or slow? Is it fast? Very fast or very slow? The double decomposition. Is it slow or fast? Fast, huh? Why? Because two solution, you put them together, then reaction occur, you form the precipitate. Okay, this one very fast. Okay, fast reaction. Neutralization, is it fast? Acid react with alkali, produce a salt and water. Is it fast? Neutralization, also fast. Rusting,生锈啊. This one is slow. How about this one? Last one. Hydrogen gas with the copper 2 oxide. Is it fast or slow? This one is also fast, very fast. Okay or not? So this one is the introduction, to let you know what is fast reaction, what is slow reaction. Okay, now for the calculation. Okay. What is the meaning of rate of reaction? Based on what you hear. Okay, change in the quantity of the reactants or products. Okay, with time. Okay. Change of quantity of reactants or a product with time, over the time. This one just define the formula here now. Okay. Now, okay, this one lead to iodide precipitate. This one is precipitation now. Okay, mass of the lead to iodide precipitate formed from the reaction between these two solutions. Okay, the mass is formed in 30 seconds. 30 seconds is 2.5 gram. Okay. So first, okay, write the balanced chemical equation. Okay, everybody you try. Okay, A and B, A and B. Okay, ready? So, chemical equation, potassium iodide react with lead 2 nitrate, no? Okay, so produce lead 2 iodide and potassium nitrate. So we need to balance the equation. This one times 2, this one times 2. Okay. So what color is the lead 2 iodide precipitate? This one. Remember lah, so it's it. Yes, yellow color. Now, set one observable changes in this experiment that can be used to determine the rate of reaction. So, class, if this reaction, how are we going to determine the rate of reaction? Okay, very simple. Huh? The formation of this precipitate, right here, the mass of the lead 2 iodide precipitate form, right? The formation of yellow precipitate. Yellow precipitate. Okay. With time, over the time. So here, class, if we look into here, 2.5 gram in 30 seconds. Okay. So can you calculate the rate of reaction? Average rate of reaction over the time, right? Okay. So here we have the mass, we have the time, right? So you just use the calculation. So mass is 2.5 gram. Over the time is 30 seconds. So later your unit will be gram per second. So you use your calculator, you'll get 0.0833, right? Gram per second. Okay. But this one is not that popular, huh? Not that popular. Normally we will use the volume divided by time. Okay, volume divided by time. Okay, huh, class? Okay, next. Sketch the graph of the mass of the lead 2 iodide precipitate against time. Okay, so you will see if initially when the times go on, definitely the mass will increase, right? So it will increase like this. Okay, so what do you think? It will increase like this all the time, or what, class? It will increase the mass until reaction completed, right? How do you know it's reaction completed already? The mass of the lead 2 iodide is become constant already, huh? Meaning that it will increase like this, and then finally it will become constant. Okay? Meaning that this one reaction complete already lah. Here. This time. Huh? Because after that no more changes. I should draw it straight line, huh? Okay. Okay, okay. Okay, next. Okay, so in an experiment, okay, zinc granules are added to the dilute hydrochloric acid. The gas evolved is collected in a bed. So the volume of gas recorded at 30-second intervals. Okay, so table shows the result obtained. So time, you can see at the time 0 until 270 seconds. Volume of gas collected. Okay, so here you can see the volume collected like this. Okay, so class, this one is more popular. Volume over the time is more popular in the questions, in terms of question, and then in the practical wise, this one also more popular. Okay, so actually, how are we going to do this experiment? So this is the apparatus. Okay, so now I'd like you to draw out the apparatus. Okay, for this experiment, we call this is a water displacement method, water displacement method. Okay, so now you draw these diagrams. Okay, draw properly. In exam, you may be asked to draw it. Label correctly. Okay, if got solution, use the dotted line. Okay, or this dotted line. Dotted line. Okay, and then be careful on this stopper. Cannot be fully immersed into it. Must be a little bit coming out. A little bit coming out. This one. Okay, so normally, a student will make the mistake here. Okay, so be careful on this stopper. Okay, another one. Okay, is the level of this delivery tube must be lower, lower than the water. Okay, so for this one, against time. Okay, against the time. So here, okay, very important here. If you're asked to draw the graph, okay, the one come first, volume of gas evolved. Okay, it will be the y-axis, y-axis, and then against what? Against time. So this one is the x-axis. Okay, then the unit must be put correctly. Volume will be cubic centimeter. Time, time. Okay, So now I demonstrate to you how to draw this graph based on the data given. Okay, so first have a look on this graph paper. Okay, let's say in exam, in the SPM, you are asked to plot the graph like this. Okay, so the graph will be given to you. Okay, don't worry. Okay, so based on the here we plot the graph. So first we have to draw the y-axis. X. Okay, you don't write X here, we write time here. We write time, then seconds. Okay. If I did each one, the X, and X. But we put 10. Yeah, I can 10. Then 2 centimeter equals to 10. Another 2 centimeter, this one will be 20. Okay. And 30, 40, and 50. Okay. Okay. Not 60 because here maximum is 48. Right. So we plot one by one. Okay. Now, a lot of students in the SPM, when they mark the paper in the SPM, right? A lot of students didn't plot this. They got they cannot have one 44. Okay, hold on. Okay, thank you, Crystal, for yeah, you let me know, because sometimes maybe it's got some interruption. Okay, you just let me know. Now sound okay or not? Now sound okay? Okay, good. Thank you, thank you. Okay, so now we continue on our graph. Okay, we plot one by one. Every points must be plotted correctly. Okay, so 180 is 47.5. So 47, 46, 47, 47.5. Okay. Then after that is 48, 210, so 48. This one also 48, this one also 48. Okay. Okay, now? So now, class, I think all of you here, okay, you also plot the graph first. Okay. And after you plot the graph, then you draw the graph. Okay. So whenever you draw the graph, okay, slowly, make sure that it is smooth, smooth graph. Okay. So now, class, everyone here, I give you a few minutes. You try to plot the graph. Yeah. Actually, my graph here actually not very smooth. Okay. I expect that you can draw a very smooth graph. Yeah, freehand. Yes. Okay. I know that there is some like the one we call it. There is one ruler. Okay. You can bend it and then you can draw the graph. Also can, but I think freehand should be okay. Yeah. So it is a curve like this. Okay. So everyone you draw first, right? You draw first. Simeon, you asked the scale must follow from the table. Yes, normally we will follow this one. Let's say here, we roughly adjust, see what is the maximum, like volume, okay? Like volume of gas here, the maximum is 48, right? 48. So we roughly calculate 50, it should be enough. Okay, so you adjust the scale. Okay, but so far in the SPM, okay, based on my experience, the the graph is very simple one, no? Very, very easy one. The scale even given already. The scale given to the student. The student just need to plot the graph, plot like this only. Okay, but who knows, this year maybe no scale given to you. You need to draw it, so you have to get ready. Oh. Okay, so I think almost done, right? Okay. This graph you must get it done, because later we need to use this one for the calculation, for the calculation. Okay. So make sure that you complete this one first. Otherwise, later you cannot follow for the calculation. Okay, class, finished already? Finish already, class? Okay, already, huh? Okay, good. Okay, now we continue, huh? Okay. So after that, after you can plot the graph, okay, now, class, now we look into this this graph. Okay, this is a volume, huh? This is a volume, this is time. Okay, so we had learned that the rate of reaction, the rate of reaction. Okay, the most popular one is the volume divided by the time. Divided by the time. In other words, if volume divided by the time, actually we can get the rate of reaction. What is the volume of the gas collected over the time? Okay, per unit of the time. Okay. So now we look into here. Based on the graph plotted, okay, determines the average rate of reaction in the first minute. Okay, in the first minute. Okay. Plus, now we are talking about the rate of reaction. Okay, rate of reaction. Okay, if average rate of reaction. Okay, average rate of reaction. Okay, you can record down. Okay, average refer to it as a duration. Okay, duration. So meaning that like this. First minute. Okay, so class, in first minute, what is the time range, class? Next day we change to seconds. What is the time range? It is from how many seconds to how many seconds? Yes, from 0 seconds to 60 seconds. So this is for the first minute. Okay, now how about the third minute? From how many seconds to how many seconds? Third minute. Have a guess? Okay, very good. 120 seconds to 180 seconds. Okay, very good. Okay, so here you can see, if average rate of reaction, normally it has a range from 0 to 60 seconds, from 120 seconds to 180 seconds. Okay, now how about the other type? Okay, you will see instantaneous rate. Okay, instantaneous rate of reaction. Okay, but sometimes you won't see this word. Okay, kadang-kadang kamu tidak nampak ini, you won't see this word. Okay, you will see rate of reaction at 70 seconds. So 70 seconds actually is a specific time, very specific time. Okay, this one also specific time. No range, okay, no range. Okay, ini pun tak ada range, no range. Okay, so actually for this kind of question, okay, the way to calculate the rate of reaction is different. Okay, so for the average rate of reaction, actually for us no need to use the graph. We can directly get from the table. Okay, we get from the table. Okay, what is that means? So if like this, first minute 0 to 60 seconds, right? Okay, we go to the table. Okay, 0 to 60 seconds, right? Okay, 0 to 60 seconds. So what is the volume? 0 is 0. Volume at 60 seconds is 35.5. Sorry, 35. So just now we say rate of reaction, volume divided by time, right? Okay, so here, a rate of reaction at first minute, meaning that the volume, remember, always remember volume divided by the time. Okay, some students make the mistake of time divided by the volume, and it's wrong. Okay, so volume just now from the 60 seconds there, so is 60 seconds is 35, right? So 35 minus 0 seconds is 0. Divided by the time, this one is cubic centimeter. Time is 60 seconds. The initial one is 0. 0 seconds, 0. So seconds. So use your calculator. Okay, what is the value you get? Okay, 0.583. Okay, 0.583 unit cubic centimeter per seconds. Okay, this unit must be correct, huh? Must be level also. Okay, okay. Now, can you calculate this one? In the 10 minute, the time range is 120 seconds to 180 seconds. Okay, so use the same formula. Okay, can you calculate it? And then once you get the value, okay, you can type the answer. Okay, so class, anyone, you get the answer? Same? Still the same? Maybe you can calculate again, Crystal? Okay. Unit now, really? Make sure that you put in the unit also. Okay, good. Okay, so I think okay, so I think most of you get it correct already, huh? So SM is the volume divided by the time, okay. So volume at 180, we use a big one minus the small one now. So 180 is 47.5, right? Okay, minus 121 is 27.5. Okay, correct, huh? Okay, so cubic centimeter divided by the time. Time is 180 minus 220 seconds. So you get 0.0583 cubic centimeter per second. Okay, now class, you can see sometimes in the exam, okay, you may feel confused. How many decimal place I need to put? Okay, so like this, I will suggest you to put at least 3 decimal places, but 2 sometimes is accepted also. Okay, 2 to 3. But for me, 3 will be better. Okay, 3 decimal places. Like this will be 0.058. Okay, cubic centimeter per second. But actually, if you put 4 decimal places, also not wrong. That's not wrong. Okay. Now, plus I add in one more question. If I say I ask you to write overall rate of reaction. Okay. Overall rate of reaction. Okay. Means the until it complete now, right? So what do you think is the time range? Overall. From what time to what time? So how many seconds to how many seconds? Okay, 0 to 270 seconds. Okay, any other suggestion or any other answer? Beside this, overall, overall means from 0 to the end. Okay, any other suggestion or any other opinion? Okay, 0 to 210. Okay, now, okay, Simeon, why you say you feel that the time is from 0 to 210? Why not 270? Simeon? Okay, very good, Simeon. Okay, because you see, class, after 210 seconds, for 48, right? 240, also 48. 270, also 48. In other words, the reaction already completed here. Okay? Because after that, you see, no more change, no change anymore. Okay, huh? So in other words, the time for the reaction to be completed is from 0 to 210, not 270, huh? Okay or not? So everybody here Okay, please pay attention. A lot of students will check from 0 to the last one. Not necessary. You must be alert. See whether the time, the volume is constant or not after that. Okay, right? So meaning that if like this, average rate of reaction will be volume from 0 to 210 seconds. Okay, so now class, can you calculate for this overall rate of reaction? What is your answer? 210, huh? Okay, 0.229. Okay, 0.229. So how about the others? Any other answer beside this? Okay, how about the others? All get this answer, class? Mm, 0.229 seems like it's correct. So you just check. Okay, volume is 48 minus 0. Time is 210 minus 0 from 0 to there. So 48 divided by 210. Yeah, 0.229. Okay, 229 cubic centimeter per second. Okay, very good. Yeah. So class. Okay, so this is the first type. So I put it in this type 1. Type 1. So it has a range. Time range. First minute, third minutes, like this. You'll see like this. Okay. Now we look into the second type. Second type. Okay. Type number 2. We call it instantaneous rate, but sometimes know this word. A rate of reaction at 70 seconds, at 120 seconds, 180 seconds, and so on. So like this. Okay. This one must use the graph. Okay. You cannot use the table. Okay. You cannot use the table. So you must draw the. You must get the answer from the graph. Okay. So I will tell you the student mistake. Some of the student they will do like this. Okay, 70 seconds. Okay, they will go to the table. Okay, 70. I cannot see from here 70. Okay, here and get this volume. Then the volume divided by the time. Cannot. Okay, you cannot do like that. Or 120 seconds. So 120 seconds. So 44 divided by 120. You get the volume. So cannot. It's not like that. So what is the correct way? Yeah, correct way. So for this one, you have to draw the graph. Then from the graph, you need to find the gradient. Okay, find the gradient of the curve. Okay, so how to find the gradient? Okay, now I show you the step by step. Okay, follow closely. Gradient of the curve. Okay, so here is 70, right? Okay, we look into the first example. First question, 70 seconds. So 70 here. Okay, so 70, where are you? So let me see. Biggest already. 70. So 60. So each one, how many? 10, 10, 10. So each one is 3, right? 3. So 63. 63. Let me see. How many 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. 10 is 30. So 3. Okay, 3. So 63, 66, 69. So roughly is here now. 70. Huh? Okay. So how? Okay. So use the ruler. Use the ruler. I try. Try mine. Because here is. Okay, use line. Okay. So use the ruler. Okay. Draw a line here. Okay. Oh. Cannot. Wait. Okay, like this. Okay. 70. Okay. Exactly 70. Okay. Here you put a mark here. Okay. So this is the mark. Okay. Draw a tangent to it. Tangent, what is that mean? Okay. So tangent here. Okay. So tangent. Okay. It must be outside, no, outside the curve. Outside the curve. Okay. How long it is? Actually depends to you. As long as you can read the coordinate. Okay. So for me, I will extend to somewhere here. Easier for me to read the points. Okay, like this. Okay. Oh. Alright. Suddenly alright. Oh, I close it. Okay, So you may stop at different point. Doesn't matter. Okay, as long as you can read the coordinate here, and then coordinate here. If you feel that this coordinate is very difficult for you to read, then you can extend longer until you can read it. Okay, until you can read the coordinate. This one also. Okay, and then if you don't mind to stop here, you can extend to here because this is 0, 0. Then here is easier to read. Okay, I think I also want to extend here. Easier to read the coordinate. Okay, everybody you can try also. Use your ruler. Okay, extend it. Okay, maybe I extend to. Okay. So maybe I send it here. Okay, the tangent cannot go in, cannot go like this. Okay, so roughly here. Okay, touch the point there. So roughly here. I think you. Okay. So. I want one more time. One more time. Okay, I think I can do it here. Cannot. Use ruler, ruler easier. Okay. Okay. Oh, yeah. No, not good. I want to make here. Okay, like this. Okay, roughly like this. Okay, so I want to take this point. It can, I want to take here, but if I want to put it here, and then I want to take this point. Okay, so you can extend now. It's up to you, based on your own one. Okay, now I want to read out the coordinate. So this one is roughly 140 x, x first, then y. 140, let's say 100. So 6, so 44, 144. Okay, y is 50. Okay, y is 50. Okay, how about this? This one x is 0, easier to see. Then this one is 25, 26. 26. Okay, so I would like you to find your own, not necessarily follow mine, maybe slightly different, also never mind. Because for this instantaneous rate of reaction, it has a range. Okay, it has a range for this one. Because every one your point might be slightly different a bit. Okay, so you get your own point already, class. The coordinate. Okay, so this is mine. So at 70 degrees Celsius, 70 seconds. Okay, so same case of volume divided by the time. Okay, volume divided by the time. So volume just now is 50, 26. So 50 minus 26. This is for volume. Okay, so always remember volume divided by the time. Time is 144 minus 0 seconds. So you will get, okay, use your calculator. So you will get, if my one 0.167 cubic centimeter per second. Okay, so roughly the answer, accepted answer from 0.067 to 0.267 cubic centimeter per second. Okay, your answer should be inside this range. Okay, that we say is plus minus 0.1. Okay, so you calculate yours, see whether your answer is in this range or not. If very far, maybe your tangent is wrong. Okay, your gradient is you have all. One is your gradient is wrong. Okay, another one is your coordinate, you read it wrongly. Okay, so class, I would like you to try. See whether your range is inside this one or not. Okay, 0.142, yes, in the range. Yeah, okay, accepted. Okay, good, really. Okay, how about the others? Okay, how about the others, class? Okay, Belinda, how about yours? Darren, what is your range? Ivy? So far, only really you managed to calculate? How about the others? Okay, 0.133 is kept inside the range. Oh, now, if you can try, okay, keep trying, okay, as long as you get the answer inside this range, there should be no problem. Oh, okay, now we try the second one, 0.08, no, 08, okay, can, because inside there is 0.67, Ivy, okay, can. Belinda, Darren, Siyang, is your answer inside the range? Okay, you keep trying, huh? Okay, now, then we try the 120 seconds class. 120 seconds, okay. So inside the graph, okay, you just continue, don't erase this one, no need to erase. Okay, you continue. So 120 seconds, so draw a line here, and then draw a tangent, and find the gradient. Okay, so now everybody, you try also. You try to find the rate of reaction at 120 seconds. So same case, okay. So draw a line. Okay, I use different colors. Into shape. Okay, maybe use different colors. Okay, 120, huh? Okay, here. So it's here, this point. Okay, I put it smaller, bigger. Okay. So draw a tangent, huh? Okay, so you extend, it's up to you. Here. No good. So no good. Okay, class, if you see, if you draw like this, it's wrong already, huh? So the line cannot enter to the curve. Yeah, so it must be outside, huh? Must be outside. So not good. Slightly like this. Okay. So roughly I put it here. Okay, so I find the coordinate here, this coordinate, and this coordinate. Okay. So write out the coordinate now class. So let's say this is okay, 168, roughly 168. And this one is 48. Okay, 48. Okay, 48. Okay. And this one is 0, then 30. 30 now, put it 30. Okay. So 50, 30, then 144. So I calculate volume 50, 630. 50 minus 30. Okay. Divide by time, 144 minus 0, cubic centimeter per second. So use your calculator. So 50 over 144. Okay, 0.139. Okay. Okay. So your answer should be within 0.039 to 0.239. Okay. But here you have to make sure, okay, the gradient for this one, the rate of reaction at 70 seconds must be higher than this one. Although we say the range is here, but as long as your answer, this one must be higher, this one must be lower. Okay? Then you check yours. Is it correct? Is it in the range? Okay, if you have calculated for your own answer, okay, you can type your answer in the chat box. Okay, 0.056. 0.056. Then just now, Willie, your answer is 0.142. Okay, then your answer for both is accepted because the 120 seconds one is lower, right? Correct? Okay, good, Willie. Okay, how about the others? Okay, Kansim, how about you? Adrian? Can you get the answer inside the range? Okay, good. Okay, Belinda, okay, no, Belinda. Darren, Suyang. So class, okay. So you can try, you can try. Okay, make sure that you know how to do this. Okay, now class, there is one information I want to share with you here. Okay, so let's say this is a graph, right? This is a graph. Okay, so if you see the gradient is steeper, okay, meaning that the rate of reaction is higher. Okay, let's say at this point, at 100, at 30 seconds, you see the gradient is steeper compared to 180 seconds. This one, the gradient is not that steep already, right? Okay, so meaning that here, the rate of reaction is higher. Okay, this one, the rate of reaction is lower. Okay, the gradient based on the gradient. Okay, now? Okay, so this is about the calculation of the rate of reaction. So make sure that all of you here, you know how to calculate. Okay, now, for next subtopic, okay, we are going to talk about the factors affect the rate of reaction. Okay, the factors affect the rate of reaction. Okay, so basically this one, the factors you combine with the collision theory. They'll ask you the question will ask you to explain the factors. Okay, but now in this subtopic we are going to look at the factors on it. We haven't looked into the collision theory yet. Okay, now factors affecting the rate of reaction. Okay, so you record down. There are 5 factors. Okay, there are 5 factors. Okay, so First one is the size. Okay, concentration, second factor. Okay, after that, temperature. Okay, another one is the catalyst. Okay, then finally is the pressure. Okay, there are 5 factors. Yeah, only these 5. And then the one in will normally ask will be the first 4. 1, 2, 3, 4. Okay, pressure normally the question will not ask you. Okay, maybe application can ask in the exam, but normally they will ask you these 4 factors. So we are going to look into one by one. Okay, so now we look into first one. Okay, the size. Size. Okay, now we look into these quick notes first. Okay, the total surface area exposed to the reaction is smaller if the size is bigger. Okay, so the size normally is for the solid gas or liquid. We cannot use the factor of size. The size factor only for the solid reactants. Okay, so if bigger size, the total surface area. Okay, don't forget these words. Okay, you highlight this one also. Total. Don't write surface area. You must write total surface area. Exposed for the reaction is smaller. Okay. Now, frequency of collisions between particles is lower. Here is already in the collision theory. Okay, good. So frequency of collisions between the particles is lower. Lower. Then frequency of effective collision is lower also. So rate of reaction is lower. Okay. So summary: bigger size, the rate of reaction will be lower. Okay. Smaller size is totally reverse. Totally reverse. Okay. So as maybe later I'll show you why. What is the meaning of collision theory? Okay. Right. So for the smaller size, okay, for the smaller size, the total surface area exposed for the reaction is bigger. Bigger. Total surface area is bigger. Okay. Frequency of collisions between the particles is higher. The frequency of effective collision is higher. Okay. The rate of reaction is higher. Okay, that's for smaller size. Okay. So class, what is the keywords normally you will see for smaller size? Let's say in the lab. Okay. How do you know the size is smaller? Okay, so you record down these keywords. Smaller size, you will see the words powder. Okay. The powder is referred to the smallest size. Okay, smaller size. Okay, so bigger size, what is the keyword? Okay, normally you see granules. Okay, strip. Okay, strips. Okay, so it is. Okay, sometimes you see chips. Okay, all these words refer to the bigger size. Only the powder is the smaller size. Smaller size. Okay. Now we look into this example. Okay, we look into the pattern of the question. Okay, so here, okay, this is a calcium carbonate granules react with hydrochloric acid. Hydrochloric acid. So this is the water displacement method. Okay. Now there are 2 sets, set 1 and set 2 in the experiment. Okay, so set 1, we see what is the chemicals. Large granules of calcium carbonate. Okay, calcium carbonate. Put into volume and concentration of hydrochloric acid. Okay, these are the same, right? For both set hydrochloric acid, volume concentration are the same. Okay, but set 2, you see this is small granules. One is big granules, one is small granules. So the most significant difference would be the size of class. Okay, now very simple question for you. So set 1 and set 2, which one has a higher rate of reaction class? Set 1 or set 2? Big size or smaller size? Class, based on what we discussed just now. Bigger size, smaller size. If like this, large granules, small granules. So which set will be having this higher rate of reaction? Okay, smaller size, meaning that set 2. Okay, very good. Sec2, thank you. So yes, Sec2, higher rate of reaction. Okay, so we need to Sec2 higher rate of reaction because it has a smaller size, smaller size. Okay, so this is okay. Now we look into the question. Name the gas. What is the gas released in this experiment? Okay, so calcium carbonate with the hydrochloric acid. What is the gas? What is the gas, class? Calcium carbonate with acid. Oh, okay, we learned in the chapter 6, right? Acid bases and salt. Okay, maybe you can write the chemical equation. Okay, don't be afraid now. Don't be panic. Okay, calcium carbonate. So what is the formula? Calcium carbonate, right? Okay, react with acid, correct? So it's a hydrochloric acid, huh? So how is the product, class? How is the product? Okay, calcium chloride. Yes, very good. Calcium chloride is a salt, right? Okay. What else? Carbonate. Water, right? Another one is what else? You have carbonate. Meaning that you have carbon dioxide. Oh, okay. So you need to balance the equation, huh? So this one. Okay. Okay. Now, what is the gas in this experiment? Use the name, you must use the name. Don't use formula. If like this, don't write formula. If you write formula, no marks. So the gas will be carbon dioxide. Correct? Because these two are the salt. This one is the water. Only one carbon dioxide, right? Okay. Okay, how fast? Okay. Now, ionic equation. Ionic equation. Okay. We have learned in the chapter 6 also, huh? Okay. Now, class, let's try. Okay. Soluble salt, soluble salt. Still remember? Okay. We check one by one, Calcium carbonate soluble or not, class? Soluble or insoluble? Calcium carbonate. Class, calcium carbonate soluble salt or insoluble salt? Is it soluble? Calcium carbonate. All carbonate soluble, all carbonate insoluble except the spa one, sodium, potassium, ammonium carbonate. So this one insoluble. So if it is insoluble, means it is solid, Okay. Then acid is the aqueous solution. Okay. Then calcium chloride, soluble or not, class? Is it soluble? Calcium chloride. All chloride soluble, okay, except the PAH, right? PAH. Okay, so P lead chloride, A silver chloride, H is mercury chloride. These three insoluble, These three insoluble. Others all are soluble. So calcium chloride soluble. Good. Okay. So aqueous, water is liquid. Carbon dioxide is a gas, Okay. So why we need to have this? Because we want to write the ionic equation, So only the aqueous solution we separate it to ions. Okay, solid, liquid, and gas remains. Okay, don't disturb it. Okay, in other words, calcium chloride, calcium carbonate is a solid, so we just copy calcium carbonate. So what they are? Solid, so don't disturb it. Okay. So aqueous solution, yeah, soluble salt, right? Separate it to ions. So we have 2 hydrogen ions, 2 chloride now, ions. Okay, next, calcium chloride, correct? Aqueous solution, so separate it to ions. Chloride, ions, okay? Then after that, liquid and gas remains, don't disturb it. Water and carbon dioxide, okay? So let it be, okay? Solid, liquid, gas, don't disturb, you just copy down. Okay, now compare. The same ions, you cancel, right? You see, hydrogen ions, here no hydrogen ion. Chloride, here got chloride, so this one cancel. Cancel. Okay? So the remaining calcium carbonate with hydrogen ions produce calcium ions, water, carbon dioxide becomes the ionic equation. Okay? Okay, how class? Okay. Now, okay, B1, calculate the maximum volume of the gas released in the set 1. Set 1. So here we can use the chemical formula, right? Okay. Now, you see, this is the molar volume, molar volume. So what is the maximum volume of the gas collected? Released in the set 1, set 1. Okay, class. So here is excess already, this one excess. We don't look at this, we will use the hydrochloric acid. Okay, so the question asks the step 1, step 1. So we use this one. Okay, so can we calculate? Okay, so first there are 3 steps, right? Okay, step 1, calculate the number of mole, right, of hydrochloric acid. So we use MV over 1000. Okay, so class, can you calculate it? So MV over 1000. MV over 1000. So what is the number of mole? Hydrochloric acid. MV over 1000. Okay, so what is the number of mole class for the hydrochloric acid? Okay, MV over 1000. Okay, 0.0025. Okay, everybody you get it? So it's 0.1, right? Okay, B is 25 over 1000. Okay, so you get 0.0025 mole, Okay. Now step 2, you do the mole ratio. The question asks you the gas, right? So you have to use compare the acid with the gas, right? Okay. So mole ratio. So 2 mole hydrochloric acid produce 1 mole of carbon dioxide. Okay, 1 mole of carbon dioxide. Okay. Now if hydrochloric acid used here is 0.0025 mole of hydrochloric acid. So what is the mole for the carbon dioxide here? How to get this mole? 2 to 1 means half, right? So you will get 0.00125, right? Mole of carbon dioxide. Okay. So your mole now for the carbon dioxide is only half, half. So you cannot use 0.0025. Okay, then after that, volume of carbon dioxide. So mole 0.00125 times the molar volume. So molar volume is 24,000. So here you see is cubic centimeter. Normally, given is 24, that one is for dm cube, dm cube. So for this one, so use your calculator, you get 30, 30 cubic centimeter. Okay. Any questions for this B1? Any question in class? No, Okay. Now compare the, we look into number 2, compare the maximum volume of gas released in the set 1 and set 2. Give one reason for your answer. Okay. So we calculate for set 1. Set 1 is 30, right? Then how about set 2? What do you think, class? It is the same or different? Volume. Volume of gas released will be the same or different? Class, what do you think? Will be the same or different for volume of gas collected here? Maximum volume of gas released. Set 1 and set 2. Will be the same or different, class? So we have to look into the condition. Okay, here you see. Okay, this one large size of the calcium carbonate. This one smaller granules calcium carbonate. Then volume the same, concentration the same, acid also the same. Okay. So the only difference here will be the size only. Size only affects the rate. Okay, affects the rate of reaction. Okay. So in other words, the volume of the gas release, okay, volume of the gas release in both sets are the same. Are the same. Okay. Sama. Okay. Why? Give one reason. Okay. Because the volume and concentration. Okay. In other words, the number of mole, because we use the MV over 1000, right? Okay. Of hydrochloric. Hydrochloric acid use is the same. Is the same. Okay. As long as the number of mole the same. Okay. Volume definitely the same. Because why? Because volume is the mole times the molar volume, right? Okay. So molar volume is a constant, 24. Correct? So mole will be determining the volume. So if the mole is the same, so volume will be the same. Okay. Now set 1 and set 2, just now we compare already. So set 2 has a higher, don't use faster, higher, okay, rate of reaction than set 1. Okay, set 1. Okay, give a reason why. Why? Okay, set 2, smaller size is correct. Okay, but you need to explain more. Set 2 has a smaller size. Okay, of granules. So it has larger or bigger, both can be accepted. Total surface area, exposed to collisions. Here I don't put in the collision fields here. Exposed to the reaction compared to set 1. Okay. Okay. But in the exam, most of the time we ask you to explain answer using the collision theory. So collision theory needs more explanation. Okay. But now we just look into the factor only now. Okay. Now sketch a graph of the volume of gas evolved against time for set 1 and set 2 and on the same axis. Okay. So class, students may feel confused on the same axis. Okay, what is that means? Means, wait, now okay or not, class? Cannot lag, no? Cannot see what? Okay, how about now? Is it better? Can you see my screen now? Cannot? Okay. Yeah, sometimes the line is lag, no? Okay. Now, class, you see, sketch a graph on the same axis, meaning that you draw inside one graph only. Don't draw two. Okay. So sketch the volume of gas evolved. Okay. Now, just now we have calculated already. So what is the volume of gas collected in set 1 and set 2? What is the total volume? What is the total volume? 30, right? We have calculated already. So here roughly for sketch, we can no need to follow the scale roughly. So here put 30, here put 30. Here put 0, okay. Now set 2 and set 1, okay. So both will be having the same volume, right? Okay. So I use two different colors, okay. Let's say set 1, set 1. Okay, set 1. Keep release the gas until 30, then finish already. Okay. Can I? So here roughly. Okay, cannot. Okay, so here must be a curve. Okay. Now let's say this is the set 1, set 1. Okay, set 1. Why don't label here? Because later in the set 2 actually also will end here. So we label here easier. Okay, now set 2. Okay, now set 2, we know that higher rate of reaction. So remember, higher rate of reaction means that the gradient will be steeper. So meaning that it will be steeper gradient. Okay, it will be like this. So it is higher rate of reaction. But it ends with the same place. Okay. So this is set 2. Set 2. Okay. This is set 1. This is set 2. Okay. Sometimes this one is just a sketch. Okay. Maybe I will. We can draw like this. Just maybe see clearer. Clearer. So I put it not that close now. Okay. Let's say step 1 be like this. Okay. Also can because sketch only. Okay, we'll put like this. Okay, one more time. Okay, sketch the graph. Okay, like this. Okay, so this is set 1. Okay, set 2, higher rate, right? Higher rate of reaction. So we steeper the gradient. Okay. Okay, so this is set 2. Oh, can I? Okay, ready? Can understand this one? Okay, now we look into D. The experiment in set 1 is repeated by using 50 cubic centimeter of hydrochloric acid with the same concentration. Okay, so the experiment is named as set 3. Set 3. Okay, so set 1. Set 1 initially is what? Okay, we put down this one initially is 25, right? 25 cubic centimeter, 0.1. Okay, 0.1 mole per cubic decimeter. Okay. Now set 3, okay, label as set 3. Set 3 volume is 50, but the concentration remains the same. Okay. Okay, so class, do you think the volume of gas released will be the same or not? As set 1 will be different, class. Okay, so set 1, 25 cubic centimeter, 0.1 mole per cubic decimeter. Okay, so set 2, we use 50 cubic centimeter, 0.1 mole per cubic decimeter. Okay, so class set 2, not set 2, should be set 3. Okay, set 1 just now it will release 30 cubic centimeter of the gas, right? So let's say it's 30. Okay, then how about set 3, class? Will it be the same as 30 or will be different? And then what is the volume, class? Different, right? Correct. Why? Different, no? Okay, why you can get the different? Or what is the value? This one is 30, so very simple, very simple question. Okay, how do you find? Okay, we calculate the number of mole. MV over 1000. Okay, M 0.1, B 50 over 1000. Okay, so it's double than Z1, right? Okay, so just now 0.005. Okay, good. 0.005 more. Okay, now you have the mole already, so you can find the volume. 0.005. No, because we need to do the comparison, right? Okay, comparison is half of. Okay, it's half. So 2 to 1. So meaning that now is 0.0025. Okay, how much? I don't do the mole ratio here. So directly we do here 24,000. So you get 60 cubic centimeter. It's double than the origin, than the set 1. Okay, so meaning that another one will be 60 now. Okay, so set 1, 30. Okay, so 60 0, 30. Then finish already, no? Right. And normal change. Okay. Okay. Then set 3. Okay, set 3. Same concentration, right? Okay, same concentration, same size. So it will be the same, no? Okay, same gradient, but it will produce double volume. Okay. So meaning that this is step 3. Okay. But this is step 1. Okay, step 1. Okay. The gradient will be the same because the rate of reaction is the same for both experiments. Okay, well, class. Now question number 2. Okay, this one actually is repeat now, but now we want to compare the factor law. Okay, factor. Okay, so just now I told you already, huh? So if you see the powder, meaning it's smaller size, huh? And then granules, bigger size. Correct? So set 1 and set 2, huh? Set 1, set 2. Okay. I think now I would like you to try to plot the graph for set 1 and set 2 on the same axis. So meaning that in this graph paper, you have two curve, okay, two curve, okay, set 1 and set 2. Okay, so everybody you try to plot the graph is same thing, volume of gas against time. Okay. Okay, class, have you finished plotting the graph? Okay, so you get the graph like this, like this. Okay, so volume of gas collected. Okay, then unit, label with the unit, time, seconds. Okay, so here actually this one also wrong. 0 must plot here. So you plot the curve for Z1 and Z2. Okay, correct, not class? Okay, the consistent scale, 10, 20, 30, 40, 50. Okay, then 30, 60, 90 until 270. Okay, almost the same as the sound hall. Yeah, maximum is 49. This one maximum 40 only. Okay, so class, correct? Okay, all class, the both curve, okay, you can draw it correctly like this. Okay, so class, for the rate of reaction at 90 seconds. Okay, these two I will let you try. Let you try Z1 and Z2. So we discuss again next week. Next week, the rate of reaction is 90 seconds. Then average rate of reaction for Z1 and Z2. Okay. Okay. Now we go to the A. Okay, the rate of the chemical equation. Okay, write the chemical equation for the reaction that has occurred. That has occurred. So zinc powder put into the sulfuric acid. Okay, there's some metal, right? This metal with acid. Okay, metal with acid. So you produce salt and hydrogen gas, right? Okay, so metal now is zinc. Okay, with the acid is sulfuric acid, H2SO4. Okay, salt, the hydrogen ions is replaced by the metal ion zinc. So it becomes zinc sulfate and hydrogen gas. So it's balanced. It's balanced already. Okay, class. Now I would like you to try ionic equation. Okay, so what is the ionic equation? Okay, so solid, liquid, gas, remainder. Okay, then only acid, alkali, or soluble salt. Okay, make it into ions. Okay, then you can cancel it. Okay, so everybody, you try this. I think this one can become our last question for today's lesson. So, okay, everybody try, try. Okay, so let's see. Okay, solid, liquid, gas, remainder. So which one is a solid? So zinc. So this one is solid. Hydrogen is a gas. So these two is the remainder. Okay, and this one, so this sulfuric acid is the acid. Then zinc sulfate is the soluble salt. So we list out, we list out. Zinc, pentane, sulfuric acid. So separate to ions. Okay, sulfate. So produce zinc, aqueous, right? Soluble salt, sulfate. So hydrogen remains. Okay. The same one cancel. So this one cancel, this one cancel. So remaining is the ionic equation. Okay. Okay, correct, Crystal. Very good. Okay. So this is the ionic equation. So normally this one will be 2 marks. This one also 2 marks. Okay. So always practice to write these two. Okay. Ionic and chemical equation. Okay. So class, we stop here for today's lesson.